Hi, in this lesson I'm going to cover questions number 1 through 6 on your homework from lesson 6.4. So feel free to fast forward to the questions that you need to see. In number 1 we have a long division problem. We must do it out using long division instead of synthetic division because of this 2 right here that disqualifies it from being able to use synthetic. So with long division you're going to take this first term and you're going to ask yourself how many times it will go into the first term here. The result of that must be identical match. So let's just start with 2 into 4 because that's pretty easy, and that's going to give us a 2. Next, x into x squared goes x times. 2x times 2x is 4x squared, and there's your identical match, so please move on. Next, negative 2 times 2x is minus 4x. So once again, you start with this 2x, multiply, then move to the negative 2 and multiply. Next, as in any division problem, you're going to subtract the results. Well, you're not just subtracting one term here, you're subtracting 2. So you can see when you subtract this negative right here, it's going to become a positive. So I'll just change both of those to positive. In the future, I'll just change signs because basically that's what occurs. The signs just change to their opposite. In the first terms, they cancel out because they're additive inverses. Next, I'm going to have negative 10x plus 4x, which is going to give me negative 6x. In a division problem, the next step is to bring the next number down. Now we're going to repeat that process all over again. 2 goes into negative 6 minus 3 times. Let's go ahead and multiply 2x times negative 3. That's negative 6x. There's your identical match. Negative 2 times negative 3 is positive 6. And we will be subtracting this amount, so we will be going through and changing the signs. And as a result, everything cancels out and we have a remainder of 0. And that's where we get this answer of 2x minus 3. Next, number 2 is set up as a synthetic division problem. One of the issues that you had to work through was the fact that these were not in descending order. So as you can see, the first thing to do is to set it up so that your coefficients are counting down. Next, remove the variables. You can see that the x to the 4th is no longer there. So I have 1, 8, 10, negative 26, and negative 5. I'm going to put the number negative 5 in the box because x plus 5 is a factor. It's a 0 of the function. So the value of x is equal to negative 5, and that is why the negative 5 goes here. In synthetic division, you drop down the first term, and you start multiplying and adding. So there's what I'm going to do. I'm going to do this fairly quick. And you can see that I have a remainder of 0. Now, what to do with this? You're going to add those variables back in. And you're going to start with the variable that is 1 degree less than what you started with. So since I started with a 4, this one's going to start with a 3. And I'm going to have x cubed plus 3x squared minus 5x minus 1. And you can see that's what that equals. Let's move on to number 3. In number 3, we had to confirm that the evaluation at negative 3 was equal to 10 using the remainder theorem. So the first thing I did was I ran the negative 3 through this function. As you can see, these numbers became very large, and it did take a little calculation to get that answer, the final answer of 10. With synthetic division, however, it can make this process very simple. So we're going to, again, remove all of the variables. In this problem, we had a 0x squared, so that is something you'll need to watch out for. If there is a missing term, you've got to put a marker in for it. So I'm going to drop down the negative 4 and start multiplying again. Negative 3, positive 9, and 0. You'll notice that the last number is 10, and that is the remainder. This is where the name remainder theorem comes from, because this 10 will always equal the evaluation of that number. Let's move on to question number 4. This is a question where you had to describe the end behavior. This is a parabola, so we know that both sides are going up. It's a concave up because that leading coefficient is positive. Moving on to number 5. In number 5, we have an odd degree equation, function. And with odd degree equations, we have opposite end behavior. The leading coefficient is a positive number, so as in a line that has a positive slope, the opposite end behavior, right side is rising, left side is falling. You can see that I've drawn a function that could be a fifth degree equation. Now, this terminology is a little bit tricky, so let's talk about it. As x goes to infinity, in other words, as you walk to the left, this is telling me that the y value is going to positive infinity. In other words, you're looking up. So in this problem, as you're walking to the left, the graph is going up. And as you're walking to the right, the graph is also going up. So this is not going to match this right here. Letter B. As you walk to the left, the graph is going down. As you walk to the right, the graph is going down. So once again, this is not the end behavior that we're looking for. As you can see, the answer is letter C, but let's see why. As you walk to the left, the graph is going down. Well, as you see this, as you're walking to the left, the graph is going down. And as you walk to the right, this part right here, as you're walking to the right, the graph is going up. And you can see that that's what's occurring here, and so that's the answer for number 5. And finally, let's take a look at number 6. This is a question where you want to distribute the v through this entire equation, and then the -2 through this entire equation. So I'm going to start with the v. v times 2v squared is 2v cubed. v times -8v is minus 8v squared. v times -5 is minus 5v. Now I'm going to move to the -2 and distribute it in the same fashion. -2 times 2v squared is -4v squared. I'm going to write it like this so that it'd be easier in the end to gather like terms. -2 times -8v is a positive 16v. And -2 times -5 is positive 10. Now let's go ahead and add those two together, and we get 2v cubed minus 12v squared plus 11v plus 10. And that concludes this lesson.